So let's talk about circles. Circles is like, well, it's kind of basically like the Pythagorean theorem and the distance formula, but you just sort of change the point of view. So you're, instead of thinking about just one particular pair of points, you're thinking about one point that you designate as the center of a circle. And, well, here's the hypotenuse of a triangle. Well, it's just one hypotenuse of one particular triangle, but let's think of R as being this side of the triangle. Let's think of every possible triangle we could draw with this radius. And, well, there's like, there's this center that we call the coordinates there, H and K. We have a point on the circle, which we call X and Y. So maybe it doesn't matter exactly, well, maybe just for the sake of argument, let's say the X and Y axes are here. So this could be like 1, 2, 3, 4, 5, 6. Just if you wanted to have maybe the radius is 5, and maybe this coordinate is 6, 3. Anyway, well, the Pythagorean theorem says that a squared plus b squared is equal to, well, whatever you call them, the hypotenuse, r. From the point of view of a circle, that r is the radius. Is that, radius. I believe we're still in section 1.1. Anyway, so we take any old random point on the circle, we end up over here. Well, the whole point is A is equal to, well, some x's are to the right of the center, some x's are to the left. There's a single h and k, which are constant. X and y are all ordered pairs that could possibly be on the circle. Anyways, A is the horizontally, that's absolute value of x minus h. So x could be bigger than h, x could be less than h, and it could be over here. And B is the absolute value of y minus k. So absolute value x minus h squared plus absolute value y minus k squared. That's where we're going with this. And, well, if you have a real number and you square it, well, then it's optional. Well, it's exactly the same the other way. You could write down the absolute value bars. It's usually customary to just write it as parentheses x minus h squared plus y minus k squared is equal to r squared. So, this little example here, what do we have? It's basically h is equal to 6 as the x value for the center. 3 is the y value of the center of the circle. R was, I started drawing and I got roughly 5. So that's it here. So we've got x minus 6 squared plus y minus 3 squared is equal to, that 2 is not the best, let's do a slightly better one. All right, is equal to 5 squared. So right, so not too bad. What makes the kind of problems that I didn't see any. I think later in the book we see ones where we have to. Well, if these were multiplied out and you had, like minus 12x plus 36 and so on, it would be a little bit complicated, and having to work backwards to get into this form would be kind of tricky. But for now, we're just learning how to recognize the ones that are already nice and in standard form and what to do with it. So this is the standard form of the equation of this particular circle, and in general, that's the equation of a circle. So there's only two question types, and one is you start with a formula and you figure out what's the circle, and then the opposite is you find the circle and then you write down the formula. So let's just do a couple routine things, and then maybe we'll address the one mistake you can make if you're not quite being careful. So let's see. So let's do one. So just fine. So there are a few things you have to look out for. And let's do that now. Okay, so right away, this might look a little weird. All right, so the first thing you might notice, it's a little weird as well. The equation of the circle, it has to be minus. And so there are two things that kind of stand out to me about this that you just have to deal with. One of them is this. Oh my, that's not quite what we wanted. And one thing that can really, it's really tempting if you go too fast to not see this, is that this is, well, it's 7 to the first power. It's just 7. I didn't write that down as anything squared. And there's supposed to be something here. So what's tempting is, well, it's not 7 squared, so this isn't 7 squared. It's something else squared. And well, there is a standard trick for that. If you take a positive number, it is the square of its own square root. That's the whole point of square roots. Well, whatever it is, my calculator says, well, 7 isn't 7 squared. 7 is the square of something else. It's the square of the square root of 7. So then we're good. So that issue's taken care of. And similar to that issue, well, here is we have a plus and we want a minus. Well, a positive number is just the negative of its negative, or adding a positive number is the same as subtracting the negative. So that's issue number 2, and we can fix that as well. All right, so now I just want to remind you, if you feel like you're up to the challenge, you can always pause it and try to do it for yourself. And if you get it right, then you feel good. And if you don't get it right, nobody has to know. There were 2 challenges here, and now we've addressed both of them. So now the center is what? We can actually give the correct answer now. X minus, well, here I've written it as -2 is h, y minus +3. the radius, so the square root of 7. And I was looking at some of the MyMathLab stuff, the MyLab. They keep changing what they call things. I think it's just called MyLab now. But whenever they ask for free response, like in like 2 or 3 weeks, there will be a small, just a 50 points out of the 1,000 for the course test, a test for not that many points, but you definitely have to do it. And the automatic grader, usually whenever there's a free response, they ask it to the nearest 1,000th. And so it's 2.64. The next one actually rounds up, so it's 2.645. So this 5 rounds up to a 6 because it's 7,513. So MyLab is going to ask for that many decimal places. So like unless you're like doing something super duper delicate, like for a space, for a rocket that goes into outer space and it's super duper crucial, that many decimal places is like if you're just painting your house, you want to know how much stuff you buy at the store. You take that number, maybe even round up a little bit just in case. But there it is to the nearest 1,000th. So that's it. So so these kind of problems are a little bit more challenging because when it writes it down with the algebra, it's not always. Sometimes it's really close to the standard form, but not quite there, and you have to fix it. And what else do we have? We have, so I'll try to draw a nice picture if I can. Let's say the center is at 1, -2. And let's say the radius is 1, 2, 3, 4. Sure, let's make it 5. 1, 2, 3, 4, 5. So if you start right at the center, and if it's lining right up with the axes, then that's a really good way to get the radius. Is you either start at the center and you go directly up, or you go directly to the left or the right, and you'll be able to eyeball it pretty instantly. So 1, 2, 3, 4, 5. If I'm drawing this really, really well, I'll at least get this much right. You know, 1, 2, 3, 4, 5. So this is -2. 1, 2, 3, 4, 5 is -7, and it goes down here. I accidentally bent it too sharp too early. Definitely did not look quite like a circle. That's okay. Computers can do this really well. Humans have a hard time. And you know, if I put this on a test, I'm definitely going to have a computer do it because this is you have to be like some kind of super duper art genius to freehand this much better than that. All right, well, the whole point was, well, center is 1, -2. Radius is 5. 1, 2, 3, 4, 5. Equation, so this means the final answer is, let's make room for it over here. Don't need that anymore. Equation x -1 squared, and then plus y minus -2 squared is equal to radius squared. So for homework, I would accept that as a final answer. There will be practice tests, so before you even take the actual test that's worth points, I know some of the free response problems are a little bit finicky on about how you write your answers, so it's a little annoying, but if you do the practice test once or twice and figure out what kind of things it's finicky about, like it probably, oh dear, but that's squared. It's supposed to be on the outside of the big parentheses. So this, there we go. So that makes a big difference. This whole thing, the whole y minus -2, that whole thing squared. So that could be a y plus 2, and maybe the electronic grader is might be really finicky about that. But for the first homework with that, I'm going to grade manually. This looks fine to me. Either one. All right, so that's roughly about it. I could give you the equation and then ask you to draw it. That's the other thing I could do. So this board is really small, so it's kind of tricky, but there we go. There's the example 2, and then the equation itself is down and to the left. The final answer. And for this example number 2, it's like I might not, pretty often I'll just give you the picture, and especially if it's multiple choice, like if they say the radius is 5 or if they say the radius is 25, you'll definitely know which one is correct because this is nowhere close to 25, things like that. If I ask you to eyeball it, then either it has to be approximately, clear that you had the right idea, or the multiple choice, the other answer is going to be so far away that there's no way you can get the wrong one. Just to be a little bit careful. That's basically it. So let's maybe just throw in one more. Let's just practice drawing given the answer. So let's, I don't want to have to erase the entire other side of the board, so I'm going to erase just a little bit here. Well, you can rewind if you need to. Let's just let's make this example 3. So I want to reuse this. I've already figured out the center and the radius. Sure, if we started with this, we could do a little bit of algebra to get to here and then figure out what it is that we're drawing. But at any rate, we've got a circle with center -2, -3. And the radius is the square root of 7, which is 2.6 something. So it'll end up, a little more than 2.5 going up, and then so going down, it's also 1, 2, 3, but it's a little more than 2.5. So somewhere about there, 1, 2. Here's 3, but it's actually 2.5. A little more than 2.5. 1, 2. You don't have to do the entire scale, but you should have at least a couple of reference points just so I can see what pattern it is that you're continuing. We'll go to -2. We take 1, 2, not quite 3, we take 2.5 steps to the left. And then this, well, yeah. This is really, really tricky. This is the kind of thing, if I don't know, maybe this is easier with pencil and then you go over it in pen when you're done, which is however you want to do it. If you do it in pen and it's not the prettiest, but I can tell that you're trying to do the right thing, it's not too much of a concern. So yeah, all this stuff. Example number 3. That's multiple steps. Well, first you have to simplify it to a standard form, and then from the standard form you can read off what's the center and the radius, and then it's drawing a circle. So just wanted to include like one of everything. So hopefully that's not too bad. The only reason is long as I wanted to cover like every kind of variation you might see. So I hope that's good. And we'll move on to the next thing. And I'm thinking like, in general, the homework that's due a week from Monday will be posted on either Thursday or Friday of the week that's comes, it's either on a Thursday or Friday I post a homework, and then it's due a week from Monday. So you get a chance to attempt it over the weekend, and then maybe you get stuck on something, and then you can talk to each other. You shouldn't do exactly the same problem. You should make up or find a similar problem in the book. Talk to each other about that. You can use the discussions and everything. And then, because, there's a whole other week and then another weekend before it's due. You should really, if things go well, you get it out of the way, and then that's one less thing to worry about. But if you really need the extra time, you'll have it. So there it is. All right, so good luck with that.